Okay, biology teachers, let's get started. If you haven't downloaded the documents that are connected to these links, go ahead and push pause and do so they're on your computer at least. And if you have the ability, you might want to print one or two of them. Okay, so let's get into the biology EOC test item specifications. What you'll notice is I've pulled out only the ones for the first 9 weeks so we can look at them in exclusion and dive deep into each one of these. If you're not familiar with the benchmark naming convention, let's go over this really quickly. The SC means science. The 912 is the grade level band for high school. L is one of the 4 big ideas we have in science. L is life science. P is physical science. E is earth science. And N is nature of science. 18 is the big idea, or what they also call the standard. In this case, 18 represents matter and energy transformations. And 12 is the actual benchmark. The first thing you'll notice down here is a reporting category. In biology, there are 3 reporting categories on the biology EOC. This one is molecular and cellular biology. Another one is classification, heredity, and evolution. And the third one is organisms, populations, and ecosystems. These are the 3 different reporting categories that we receive our test EOC performance back in student level. Let's look at this benchmark, which is the first one that you see in your curriculum map. It's L1812. Of course, this is the one that deals with the properties of water. And when you go down, you'll see the benchmark clarification, which is actual expectations of what we want our students to learn, and then the content limits. Content limits show us only as far as we have to go. Of course, if you are confident that your students are performing at the level at the benchmark clarifications to mastery, there's no problem ever going deeper than the content limits ask you to. But at the very least, you must make sure your students are performing at mastery with the benchmark clarifications before you go deeper. Stimulus attributes, these are the things that will give you clarification as to what your students will be exposed to. In this case, of course, scenarios must have a biological context. This is for the biology classroom. Sometimes they'll give you clarification, for instance, if there was going to be a need to display temperature, and the state of Florida has decided they're going to always use degrees Celsius in anything that they display in any kind of graphic, table, or any other representation on the test. Then they would make sure they have that clarification for you that it would only be represented in degrees Celsius. Therefore, you should always expose your students to the degrees Celsius so they understand and know what they're talking about. Even though we have none specified response attributes, what they are is they're defined characteristics of the options from which a student must choose to answer the question in the state test. So they do provide us prior knowledge in the standards that are somewhat related and aligned to what is expected in this case. And you can see 6 means 6th grade and 8 means 8th grade. So there's some relation to the content that's expected into the properties of water here. And they had some exposure to it in 6th grade and some in 8th grade. Some items have a sample item that's been released. Keep in mind, they're released from the state test for a reason. They did not perform well. They did not have high reliability, so they went ahead and let us have exposure to the not so good test items. Keep that in mind, but at least you can see some ways in which they word things and some examples. So my recommendation to you is dive into these test item specs documents. Move through this. The L18.1 is, of course, macromolecules. Go through that one deeply. And this one also assesses 1811, which is your enzymes. Look through this one, and that deals with those 2. That's the clarifications for those 2 standards, which rounds out what DIA1 is. Once you move to the next page, now we're starting to go into DIA2 content, L14.1, and then you'll see this one is an N standard, and you'll go, why do we have an N standard when I have L14.4 is my next one? Well, that's because this is one of those, this is an essential parent standard. Sometimes in biology we call it the keystone standard, and they also assess other standards. So you'll see right here, we have the 14.4, L14.4, compare and contrast structure and function of various types of microscopes. This is the microscope standard, and it's embedded in the processes of science. And the last one, your parent standard is, or the keystone standard is 14.3, L14.3, but it also assesses L14.2, which are the last two standards for DIA2. Both of the clarification and content limits for both of those standards are on this one insert for the test item specifications. Okay, let's move into your curriculum map pages. Now, these curriculum map is just after week 2, because I know SMT 1 will be performed during week 1, and then SMT 2 we have the standards off to the right and then the unpacking to the left. Why I want to bring this up is to have you realize that when we bring up the teacher hints here, you'll see that some of the verbiage we pull it directly right from the specs documents, but due to space basically and format, we can't get everything that's on the test item specification documents in the curriculum map. So an important thing to remember is your test item specs document, that's the first thing you do when you analyze the standards. Then you go ahead and go to the curriculum map to see how we have unpacked them to give the students, performance statements. Quick reminder about the science practices they're on page 9 of every curriculum map, but all 8 of them are listed here. Remember, the QR codes link you to the Paul Bozeman explanation of each one. And now that we have been building our repertoire, you can see how we would naturally include developing and using models on the regular. That we're going to have our students doing their initial thinking models, which lead them to asking questions. You may have them ask for further clarification on their questions and defining the problem of which they're asking the question. The cool thing about this is it leads to student-planned investigations that they carry out to try to solve the phenomenon. And then ultimately they may be analyzing data because of this investigation, or using some mathematics and computational thinking. When they ultimately have some information that they can construct explanations of the phenomenon, or they can make a claim based on their evidence and their data to provide support for a claim, so they engage in an argument from evidence. The key thing is, during the first 9 weeks, every 9 weeks, there should be multiple exposures to all 8 of these. Some more than others, most likely, but definitely having an intentional exposure to the students doing science. And these are the science practices we're looking for in the classrooms. And lastly, don't forget, this link is to the candidate phenomenon template, which you may utilize in order to write down your initial thinking. I know in biology we have multiple different topics, but it's up to us to figure out how, if any way, could we have a 1 or maybe just 2 phenomena for the whole 9 weeks that we could have all the standards connected to. That's where our minds need to come together, because no one person can figure this out. And that was the purpose behind putting your initial thinking on this candidate phenomenon template. And then ultimately, go ahead and when you get to the Padlet, throw out your ideas. Don't be apprehensive or nervous about it. This is a place we all can come together safely and share ideas. Your initial idea may not be super strongly aligned to a standard, but you may provoke thinking in someone else's mind, and that helps us all grow. The idea here is to get a strong candidate phenomenon. Will it be an anchoring standard? We don't know until we get in front of students, and that in fact increases the engagement level of their curiosity and questions for a long duration of time to get us through multiple standards. Anyway, I'm super excited, and I cannot wait to see the brainstorming on this Padlet, and I wish you all the best of luck, and I can't wait to see it.